that it is at no cost for everybody. We have a lot of videos on YouTube, and you all can grab a hold of them and use them. And about 6 months from now, we should have almost double, probably at least double the safety videos, because we're going to really ramp that up because it's working. So part of what we do as far as the safety is it's going to be interactive. You all can ask questions. You all can interrupt me anytime, and feel free to do so. I'll probably answer your question prior to you asking it, so if you can hold off just a little bit. If it looks like I'm going to miss answering your question during this share here today, then interrupt me, all right, and ask your question. So we've got these flyers out here. They're Electric Culture of Safety flyers, and I went to the incident prevention folks, CUSP, Certified Utility Safety Professionals. Any of you all know about them? You heard of them? CUSP? Heard of them? No? All right, it's a good program. And anyways, you can get the Incident Prevention magazine for free every month. And in there's articles for safety, and they're no cost. So incident prevention, twice a year they have conferences, safety conferences. And last October in Dallas, I was speaking at the safety conference, and I went up to several of the well-known speakers, Jimmy Vaughn, Danny Raines, and such, and spoke to them and asked them and told them, I said, guys, I got an idea, okay? Here's my idea. I want to go nationwide with this. Okay, we're going to call it Electric Culture of Safety. I want to go nationwide with this. And I want you all to help. I want you all to share. I want you all to speak and donate and give back your expertise and your speaking and your knowledge back to the electrical utility industry that has blessed you all your life. Okay? So you guys got to give back. There's no cost. You guys got to come freely. And they looked at me and they said, we want to do it. So we do it. So since February is when we launched it with 002 Danny Raines electric system grounding. I have that on video. It's free. You guys can take it and have it and keep it forever. All right? Anyways, we have about 11 full webinars. We videographer with a professional guy, and they're all available to you all. You can register. It's real easy. The flyers are right here. It tells you how to register. It's very simple to get involved with this. There is absolutely no cost. You don't have to give us a check for nothing. You don't have to give a check to anybody for nothing. We give you. Beer pays for this. All right? And there's a lot of endorsing companies since February now. You can see them up here. Xcel Energy just endorsed this. They know this is serious stuff. And what they do is they share it with all their line crews, what we do. We have 2 speakers a month now. There's so many folks that want to do this. We have 2 speakers a month. Every month, different speaker, different topics, twice a month, every month. We're booked up for the next year with speakers. Okay? And it's all available to you all for free. That's kind of cool. All right? So it's up here. We got pamphlets that show what we do as far as a company. This has nothing to do with selling tools at all. This is just what we do to help you all. We can fly out, field training, help you out. This right here, this is all part of this. All right, Bierer USA, Utility Support Assistance. Okay. So, anyways, we're going to get started here. We're going to talk about many things, and the many things we're going to discuss and talk about have nothing to do with whether it's going to be using our tools or somebody else's products. It's the safety we're going to go over is all the same. You all need to know that every one of you all are super important. You have a lot of influence, and you're going to affect a lot of people in your life. Most of that will come through not words, but through your actions, how you work out in the field. All right, how you move, how you watch out for one another. You know that's training. Did you know that? If you're watching out for one another, you're being your brother, sister's keeper. You know that's actually training others to do the same. Huh? All right, that's going to be psychological safety. That's psychological safety right here. All right. Throughout all these years that I've been doing alignment safety and tool training, I have a lot of contacts that are safety folks throughout the United States. And the main thing that I see as far as guys getting hurt It has nothing to do with a lack of safety training or topics that they have been to and have learned at all. It has to do 100% not with the training, but it has to do what I see the biggest problem out there is right here. Folks becoming complacent, maybe they're fatigued, maybe they're thinking about this because they're hungry, all right? There's things that are happening out there in this world that come into your mind and you're focusing on these things. Maybe you lived too high above your means. Maybe you're in debt, all right, because you weren't very wise and you thought you needed this and you needed that. Then you realize you really don't need these things, okay? They weren't real. You guys, one another, that's what's real. Us being together, this is what's real. This is reality, guys, not things. Things don't have souls and don't have life in them. You guys get that? So the biggest thing that I see is folks are getting hurt because they're not watching out for each other. They're not focusing on their profession for just a moment. You guys get that? So that's psychological safety. I'm going to show you a lot of tactical safety, hands-on safety today. And these things here, you're going to hear some things and see some things that you haven't seen or heard before. But it's true. It's not electrical theory. We're going to talk about electrical reality. And you're working in this electrical reality all day long, every day. That's your job. Okay? So we're going to talk about a few things. One thing is OSHA. Brady Hansen. Anybody ever hear Brady Hansen? He's a safety trainer. He's awesome. You guys he's one of our speakers at ECOS. He does a great job. Goes around the country, consults and does training. Anyways, he says that these are the scriptures, Linemen scriptures. 1910.269. Okay. And if you go to lowercase n talks about your temporary protective grounds. Your temporary protective grounds, we're going to call them a best friend. We're going to talk about two best friends. Your temporary protective grounds is one of your best friends. So, since they're one of your best friends, it's important you should probably read up on lowercase n, 1910.269, lowercase n, where it talks about your temporary protective grounds. That's a good safety subject. Okay? And in there, if you go down and read that up, you go down to number 4. Number 4, there's a lowercase triple I. Lowercase triple I says that the IEEE 1048 and the F855 ASTM are guidelines to the 1910.269 lowercase n OSHA regulations. All right? And in those guidelines, here's the IEEE 1048. In these guidelines, it talks about temporary protective grounds. Talks about care, talks about testing, talks about maintenance, talks about all kinds of things about your best friend. So it's good to know about your best friend. Does that make sense? Right? You're trusting them with your life, so it's good to know about your best friend. So in those guidelines, you guys are going to read it. It's going to talk about visually inspecting your TPGs. On a regular basis, you're going to visually inspect prior to use. Now, I've been, for the last 5 years, coast to coast, Canada, Cayman Islands, some other places, right? Brownsville, Texas, everywhere. And there's utilities that this day, before we show up to give a lineman safety and tool training presentation, they were not training their linemen, believe it or not, to visually inspect their TPGs, ever. And if you looked at their TPGs that come off their truck, you would actually know it without even asking the question, because they're horrible. Everything we're going to talk about as far as what you don't want to see, I've seen it. All right? And many of the TPGs, I've seen multiple infractions. All right? So you don't want to see any bubble jacket. You don't want to see any blackened copper or patinaed copper or pinched cable. You don't want to see any broken strands, if they're visible. You don't want to see any broken strands. Obvious loose connections. You don't want to see any oxidization on your components, especially your contact points. That makes sense, right? Okay? You don't want to see obvious flaws in your clamps, like cracks. So you're going to be making sure you don't see any of these things. I've seen it all. All right. You also want to do a mechanical inspection. And this is important. I've been to utilities that weren't trained in this either. And we do electrical test and they fail. And I simply grab a hold of the clamp and the clamp spins right off the ferrules without any effort. So obviously they didn't do a mechanical test. So you don't want to be able to spin your clamps off your ferrules. You don't want to see that cable inside those crimps of your ferrules to be loose and wiggly. Make sure that crimp is nice and tight on those ferrules. Okay? Everybody get that? If they look good, they feel good, typically they're going to take care of you. Your best friend is going to take care of you for that day, for that moment. Okay? So it's real simple. All right. Also, we're going to go ahead and do an electrical test, which is what those guidelines say to do. It doesn't say how often. We recommend once a year. Some folks 18 months, a few 24. There's a couple utilities that don't do any electrical testing still to this day. But it's changing rapidly because of a visit. Thousands and thousands and thousands of linemen are much safer 5 years ago to today than they were. Okay, so that's kind of cool. So I'll be away from my wife just so there's guys out there that get safer. All right, not a whole lot. All right, so here's what we're going to do. When we test, we're going to test in a parallel. We're going to simulate a parallel configuration similar to this right here. Okay, so I'll twist it, which is what the instructions say to do up here. And then what we're going to do is, this is a number 2 cable. We suggest a 1-aught or a 2-aught because they're stiffer. Cables that are flimsy, they'll snap over time easier. The strands can break over time much easier. And so number 2 requires 165 amps. Some of you guys can't see this. I'm going to jack this up. Jack this up a little bit. Let's see if you guys can see that a little better. Kind of South Carolina rigging going on. Okay. All right. So what we're going to do is we're going to go ahead and crank this up. What's required, Walter Bierer, this is his first tool he created 35 years ago. Since then, you can see what happened. And what we're going to do is we're going to go to 165 amps, continuous current. Okay. We'll go a little higher. 168 amps, give or take. We have a 0.21 voltage drop. This cable here requires a 0.24 voltage drop or less, and it passes. So as you can see, it passes. We got a little heat here because these components aren't necessarily brushed too well. Not much heat, but they pass. It does really good. So keep your contact points clean. Brush them. All right? But this passes really well. You want to date stamp it. Make sure your TPGs are date stamped so that you could recognize that they're in compliance with how often they should be tested. You get called on an outage, do some storm or something like that, and you could get inadvertently skipped. So make sure that that date stamp is in compliance with your program. All right, cool. All right, so these pass, very safe. The reason why you want to test them in a parallel configuration is it's going to simulate when you're using them out in the field. When you're using them out in the field, you're going to create your EPZ. You're going to bring in your grounds, and you're going to bring them, and you're going to go from point A to point B. All right? So you're going to have some droopage maybe if they're a little long, that's fine. But the thing you don't want to have is you don't want to have any coils. Maybe they're on your truck ground or your truck reel. All right, on your truck. Make sure that they're pulled off that reel. Because if you don't pull them off the reel, they're coiled. If they did get hit with a potential fault current, then they're going to try to escape from itself. And they're going to be all flopping around. Someone could get hurt just from that alone. All right, so make sure they're out, laying on the ground, parallel configuration, that's great. All right? So what we're going to do is I'm going to go ahead and mimic truck ground right here. You all ever see a video like this? There's videos out there. They're cool to watch, but what not to do. And I got this current going up to about 300 amps or so. all right? And I can feel this through my hands. The tool's very safe, 300 amps. So this tester, well, when he came out with this, it puts continuous current as per ASTM page 2, table 1. He literally built the tool around the ASTM standards, all right? And most of the testers are glorified ohms meters. This is the real deal. So this is going to be a real situation right here. And it's built around the guidelines for ASTM. Okay? So that's kind of cool. So I want to show you guys, we got a magnet here. Okay? Got a magnet in this bottle. And you guys see that? Hear that? Okay? So what happens is we got a magnetic field that's being created by this coil. And you don't want that. Magnetic field is going to cause a little chaos. All right? It's like if you get your wife mad at you. That's what's going on in her head right here. All right? A little chaos. You guys know what I'm saying? All right? So you don't want that, have that. So what you want to have is you want to have chill. You want to have happiness. All right? So you're going to make sure you're in line with her. Make sense? Okay? And watch the difference. See? Just a little vibration. But hey, that's a good thing. Little vibration. You know what I mean? All right? But there's no chaos. And see, what happens is that coil, when it creates that magnetic field, it also creates thermal activity. It's getting kind of warm. All right? Feels good this morning. But the tool's safe. So I can touch it with my bare hands. There's no shock potential. All right? 300 amps. All right? Any questions, guys? Pretty cool. See? So you don't want that magnetic field getting all crazy on you. We have our own clamps, our own cables. So if you guys ever need a bid, you all, after we get done with the safety, is there any tools that you use from us that I need to spend a little more time on as far as the technical part of the tools? Corded, wireless, service testers, anything? Hot pot? No? Okay. All right, so you guys are still in the cave a little bit. This here is nice though. All right? So we're going to continue. All right. So on your voltage indicators, so it doesn't matter, this is what we're going to talk about, whether they're this color or another color, whether it's a different manufacturer. We use switch plate, okay? Other manufacturers might have push buttons. All right? So they all work the same. So we're going to talk about these as far as battery test. Battery test is simple. Horn and light. If you use a horn and light, just an indicator, right? You're going to see in here, battery test. Battery test is only a battery test. It is not a live no voltage source. So it's not a true tool test. Just a battery test. If you do not see in here, then you want to take out that quick change, get a wrench, there's a little quick change underneath this hot stick adapter, and tap out the 9-volt battery and replace it with a known good 9-volt battery and retest. If you still don't see, or maybe you see but you don't hear, the tool's broken, and send it in for repair. We build our own tools, have for 35 years, and send it in, we can repair and recalibrate. So you keep your tool. They're not throwaways. All right? You keep them. So, that's the battery test on horn and light. Analog. Anybody's tools. Remember, this is the same with anybody's tools. Analog, you're going to see, you want to look for that needle to deflect all the way. You want to see deflection all the way. If it does, the battery is good. Doesn't mean the tool's good, it means the battery's good. Our tools go through about 90% of the electronics of the battery test, but it's still not a true tool functionality test. But it does give you kind of an indication. I was at one utility a few years ago, a large one, and for decades they were training their linemen that a battery test was a true tool functionality test. For decades. And I simply asked them, I said, hey, where's that transformer inside that meter that you have, your device, that steps up that 9-volt to high voltage for a true tool functionality test? They changed their work methods. They stopped arguing with me. That's good. That's good. So put a new battery in. If it didn't move or it's just partial, put a new one in. And if you get the same results, which are bad results, doesn't move or just partial, the tool's broken, send it in for repair. Anybody's tools, okay? All right. A digital tool, what you're going to do is you're going to do your test, and ours gives you the voltage, all right? 8.6, okay? So it gives you the voltage. If it's 7 volts or lower, replace the battery, all right? So it's pretty simple, pretty easy to use. All right, we got bandanas also for you guys. They're left over from all the kids and the wives took all the dang bandanas, so we have a little bit left. All right, so care. You don't want to, you want to keep your tools clean. Hot stick wipes work great. You don't want any markings on the probe, no dirt, no grime, no grease. All right, so this probe is important to keep clean, and also to know that there's a line limit here. This line limit here is an indication of where you do not ever want to pass as far as a potential ground or another hot phase. All right? Don't want to do that. So the reason why is because of how the tools work. There's resistors right here. Those resistors keep the tool from being energized with primary power. All right? The resistance there, about 25 mega ohms of resistance. Because when you use these tools on a hot conductor, we're going to, or even a cold one, we're going to call that X. Energize or de-energize your conductor is X. We're going to create a formulation, a formula, an equation. All right? So X is your conductor. So if you touch that conductor, you know you have resistors here, but in order for the tool to give you a voltage indication or detection or reading, it must be energized. Doesn't it? It has to be. So these tools, no one's tools are isolated and insulated. Nobody's tools are. They actually have voltage on them. They actually have some current. They're actually energized. All right? So you don't want to bypass your friend there. Not your best friend, but those resistors. So what you're going to do, because you know that this line limit, 2.5 inches down, is where the resistors are. Anybody's tools. Okay? Not just ours. Is you're going to create a sphere. Imagination, you're going to create a sphere around this tool. Round it, all the way around it, up, over the top, underneath, behind it, everywhere. And around that sphere, you do not want to have a potential ground plane or another hot bus or something hot. Because you know this is energized. If you're touching the conductor and you've got a bleed wire, you're in a cabinet, and you've got a bleed wire next to the housing, what will happen? What will happen? It's energized, and here's a bleed wire. What will happen? Yeah, arc flash. That's the call we get more often than any other call. Okay? We get that call periodically. Not that often anymore. We used to get it a lot because the linemen didn't have lineman safety and tool training. All right? So protect, and that sphere you're going to create is going to be your second best friend we're going to talk about today, and that's going to be called your air dielectric. That's your second best friend, air dielectric. You got to take care of her. Take care of your best friend. All right? Don't come in that sphere with a ground plane or another hot phase, because you're going to see an arc flash if you did. All right? Because the components that make everybody's tools work are energized and they're conductive. You can put your stickers on that housing all day long. Okay, make sense? Okay, guys, so here's how everybody's tools work. You got the X as your conductor, plus Y. Plus Y is the tool functionality, how the tool works. All right? So how the tool works is the tool contacts with the conductor, the tool couples with the capacitance, the tool, the components of the tool, the engineering of the tool looks at the current that's flowing through the tool in relation to the ground plane. Right here, ground plane. That's how everybody's tools work. Equals X plus tool functionality Y equals Z. The Z is number 1. See, everybody's taught that here's your voltage indicator. Go out and start phasing. Corded, wireless, go out and start phasing. But did anybody sit down with you and actually discuss how they work? how they actually function. You're trusting these with your lives, hot or not. That's trusting them with your life. But do you know what you're trusting with your life? Do you know how it functions? See, that's lacking a little bit in the industry. All that's changing though. This is cool. That's why we're here. Everything's changing. So equals Z. Z is not what you're looking for as far as an indication. That's all backwards, wrong. Z equals safety and accurate information gathering, right? You're trusting these with your lives. So you want to see on the other side of the equal sign the word safety. True, right? You don't want to just take these out. Okay, we're in phase, we're out of phase. And now realize that you've been using these incorrectly and unsafe for decades and you didn't know. It never has equaled safety if you use these incorrectly. And it never has equaled accurate information gathering. Yeah, you get a pretty good idea, but it's skewed information because maybe you weren't using them properly. All right, so we're going to use them properly and safely. All right? So here's how you're going to use them properly and safely. Is you're out in the field, you've got your PP on, you're engaging in your work. And we call this, don't matter whose tools you're using, but if you're using your tool, you all have capacitive test points on your elbows here? No? Some? I don't know. I'm asking a question. Anybody? Do you have capacitive test points in your elbows? Do you? Okay. I see a couple of heads no, a couple of yes. All right. So capacitive test points are really cool to have. They're on the front of that elbow there. The dust cover, I took off the dust cover. But you can engage and verify you're hot or not at that capacitive test point. You can actually phase off the capacitive test points as well, which is kind of cool. A little more efficient, a lot safer. But anyways, when you're using these tools, you never want to use anybody's tools by tool gloving. We call this tool gloving. Okay? You never want to use them by tool gloving. This has never equaled safety, and it never has equaled accurate information gathering. Because now you're telling the tool that this is the ground plane. The tool's not designed for this to be the ground plane. When we calibrate these devices in South Carolina, we don't plug them in that feed through. We don't plug them into that hot bushing with a gloved hand to calibrate the tools. Because they're not designed for you to work like that. This right here, what you're doing is if you ever did this, or ever see this, and you will see this of it one day, and if you do, you need to have a conversation with that line worker, lineman, line lady. All right, you need to have a conversation. Because what happens is I've come into that air dielectric. Okay, so I'm telling the tool that the equation is x plus y plus me. And it never has equaled safety. It never has equaled accurate information gathering. All right? Because what I'm doing is I'm trusting a good friend, a glove. I'm trusting a good friend. Gloves aren't your best friend. They're a good friend. But sometimes good friends can let you down. Best friend won't. All right? So you don't want a tool glove. Also, when you're using these on your stick, it's really important that you're going to stay back minimum 31 inches because of arc flash measurements, but most folks are going to 36. I prefer 36. Hand guard, you can get a hand guard put on your sticks, not these, but your sticks. I've had guys tell me, well, they just use electrical tape to kind of indicate where their mark is, what their work method's trained, what they teach. And that's fine, whatever. Have something there so it's easier to remember as well. And plus, if you have something that's there for you to hang on to or look at, other brothers that are watching you can see that from a slight distance and verify that you're working safely as well. You see how that works? It's a visual indication. And here, when you're back on your tool, you're keeping your air dielectric. See that? That air gap. Visible air gap. Confirmed air gap. Now, if you're in here, this is called short sticking. Okay? And short sticking has never been safe. X plus Y plus U does not equal safety. nor accurate information gathering. Y'all get that? Pretty cool. Okay? So you don't want to be doing that. You're going to see guys are tired. You know, they've been doing this a long time, and they'll go ahead and do things like this. You don't want to do that. Watch out, others don't do that. So we're going to talk about anybody have any questions thus far? Yes, sir.
So nobody ever taught us that with our red tools we had?
Yes.
We went up in the bucket and tried to test the phase, and it don't work without a stick.
Yeah.
How does that tool know based on the stick? Or why does it work on a stick but not in your hand?
So our tools will work in your hand. Okay. That's good. So you're going to put them on a stick, then they work. Good. Get away from it. That's good. I'm not sure as far as the engineering of your specific tool, but they do all work the same. But if you're holding it in your hand, then you're coupling with that capacitance as well as far as a ground plane, and you're not allowing that current to flow properly to the ground plane here. You're interfering with that. You're into the equation. So yeah, always keep them on your stick and back away from that meter head. Remember, they're energized. Okay? Good question. Okay, guys, this here is a corner pole. Okay? Not very straight, you know, but if you go to Texas, you'll see a lot of these angled out. Not very straight, but that's fine. So I get a call from a lead lineman out of Illinois, Northern Illinois, a cooperative, and he calls me and says, hey man, your analog tool is giving me 13,000 volts on 7200. And your tools, we've been using them for about 6 years. We got them recalibrated and they're broken, they're not working. We're losing confidence in your tool. So if you're phasing 7200 and you're out of phase, let's say you got a corded device, you're out of phase, you're going to see close to 13,000 volts, right? Close to that. So when he called up and said that, then I knew right away without further discussion, I'm not going to argue with the guy. I said, look, I'm going to get a plane ticket, fly out, and we're going to do some lineman safety and tool training for you all because you need it. Keep the tool. Tool's fine. So he's like freaking out. And I got there, we did indoors. And here's, after the indoors, he went back out. When he called me, here's him in the bucket. Here's a corner pole. He makes contact. Improper body position. You guys see this? Improper body position. Short sticking. My back is to my enemy. I got these three phases flowing right behind me. Why would my enemy be to my back? When you're working hot, always consider that potential your enemy. Because if you touch it, you'll know why I just said that. Okay? Because it's trying to go home. Your temporary bodies that you're residing in right now, your tents, are dirt and water. Okay? Ground. If you allow it to go home, it's going to go home. So here's him. So here's improper body position. What was happening is his body was coupling with capacitance on these phases behind him. Flowing across his body, through his body, across his gloves, through the tool, the opposite direction it was designed for. And the conductor he was touching, that potential was flowing across the tool to looking at the ground plane, this direction that it was designed for. So he was literally a wireless, living, breathing phasing meter out of phase. All right? After the class, he gets up there with the broken tool. And he gets up in his bucket, and here's him in the bucket. Proper body position, away from his tool. 36 inches. His enemy is in front of him. The tool is in the exact same location as when he called me. The tool did not move. His body did. Proper body position, enemy's in front of him, proper body position. Y'all see that? Pretty cool. Bless you. Y'all see that? All right? His tool, when he made contact with the conductor, that broke tool said it was 7,400 volts. Wireless analog. That's pretty close. So the tool is miraculously healed. You guys see that? Miracle. See? All right? So he learned something that day. Another guy calls me from Louisiana. He's eating a little too much gumbo or something, I don't know. And he called me up. He says, hey man, I'm using your horn and light. And he's at a corner pole. And he said, hey, your tool's broken. I asked him, I said, did you test your tool on a live no voltage source? Yep. Did you test your battery? Yep. Everything's perfect. And I said, your tool's not broke. And he said, yes, it is. He said, the switch is open and I'm getting a false positive on the conductor. Oh, really? False positive. Okay, so show me a video. So he did the video. The switch is open. That's cool. Here he is in the bucket truck. Here's a corner pole. He's got his back to the enemy, short sticking. And his horn and light, he makes contact with that long source. And his horn and light is going off. Seeing the lights, hearing the horn. So if he makes contact with that conductor and the horn and light saying that that conductor is energized, he's got improper body position times 2. 1, 2. Is that conductor energized or is it not energized? Was the tool lying? Was it a false positive? Or was it actually true? You guys know how this works now. Was it truth? Truth. That's right. Because you know how electricity works. It's not a theory. It's flowing right through his body, crosses gloves through the tool the wrong way. That conductor was energized because of himself. He's the switch. And he's in, but he's a little out. So a little schooling, a little education. 5 years ago that happened. I haven't heard from him since. The broke tool is healed. Okay? That's what we do around here. All right. So these things are important, guys. We're going to talk. Let's see. I think I'm ready to energize. Yeah, I am. All right. So let's go ahead. I'm going to turn on that generator. We're going to backfeed these 2 pad mounts with 120 208. We're going to have 120 208. Well, we'll call that 7200. Here we have 19.9 34.5 for reals, 3-phase. And then we have a 3-phase cabinet, 120 208 as well. All right, so let me turn on that generator, and then we'll get energized here. Hold on.
Do we have any Bierer meters? Not that I know. What are they, Hastings, I guess? Everything's pretty much Hastings? Okay.
I think. Some HD voltage indicators.
Any other questions, guys? Any other questions? Anybody? Good so far? Yes, sir.
Any questions about like induction, reduced voltage?
Yeah, that's a good question. We're going to talk about that now. All right? And this is actually a super important question. And this, to me, is something in the OSHA regs that needs to be changed. Personally, you know what? Hold on, guys. I didn't flip the switch on the generator. All right, so don't get close to these.
You turn it off?
Hold on.
Coco and I have a heart attack.
Okay, we're going to talk about induction. We're also going to talk about backfeed. This is a big subject. And so again, real quick, that OSHA 1910.269, talking about lowercase n. TPGs, temporary protected grounds. You're going to go down to, we talked about number 4. Now we're going to go down to number 5. And number 5 talks about how you're going to use a tester. Use a tester. And you're going to test and you're going to verify prior to installing your TPGs, you're going to verify that there's an absence of nominal voltage, your system voltage. An absence. But on your question, your point, I believe that needs to be changed. I think it needs to be changed for, we're going to talk about an absence, not only of the nominal voltage, but we want to see an absence of backfeed and or induction. All 3. I think it needs to be changed. Okay? It should be changed. And the devices being used by linemen need to be accurate enough to give you that information. I do a lot of training around the country. I was just at North Line Utilities in August, north of Syracuse. They had a big annual safety conference. I went up there and did a little speech. Anyways, I talked about what we're talking about right now. And if you all, or if you know or go to a utility ever that uses non-contact indicators, they need to be chunked. Okay, chunk it. That's a word I learned in South Carolina 8 years ago when I moved there to work with my family. The word chunk it is one word. It's a southern word. And it literally means throw it in the trash. The reason why you want to chunk a non-contact device is because you will get false positives, false negatives. You will get skewed readings. If you have other sources nearby in a tight cabinet, if you're on an underbuild, you're going to get skewed readings. And what happens is you become really good at guessing. You become really good at being presumptuous, thinking you know it all. But you really don't have direct contact. So you really don't have that knowledge, that true knowledge of direct contact that you're going to know that you know without guessing. Okay? So non-contact tools, chunk them. All right? So we're going to use devices that are going to verify an absence of all 3. Nominal, backfeed, induction. Okay? All right. So, for instance, you guys don't. Some of you guys have capacity test points, some of you don't. So what we're going to talk about is we just got this new meter. Like, this is actually a prototype, and this meter does secondary voltage. It's got a secondary switch. Like if you're in one of these little cabinets, maybe you're on 277, 480. And then it's got a URD, 99.9 kV, and an overhead, OH, overhead, 99.9 kV, overhead transmission. I heard you guys, Kurt told me you guys do some little transmission. So put it in OHT, overhead transmission, takes out the decimal point. Now it goes up to 999 kV. So this tool here, standalone, does all your secondaries, overhead, underground, transmission. Kind of cool. We just came out with this. Brought it to the Linemen's Rodeo. Eversource Energy is like, they were going to buy a whole bunch of VD1000s, and I shared with their tool methods this new one. They're like, oh, we got to change the PO now. So they like this one. Anyways, so what you're going to do is you always want to make direct contact. You guys do underground and overhead, right? Both? Yeah, okay, good. Good. So you're very familiar. Our tools are the only voltage indicators made anywhere in the industry that discriminate between underground and overhead. Because we know how tools work. We know that they are energized and they look at the current in relation to the ground plane. So if you go underground and you're close to the ground plane, it's going to be more accurate. See? If you go overhead, you're further from the ground plane. So put it in OH, and it's going to be more accurate overhead for you. Because you're telling the tool you're further from the ground plane, the tool's going, okay, let's go. Cool, easy. Pole just fell over, little storm. All right, so what we want to do is, OSHA, basically you guys are trained open test ground, right? Open test ground. How I like to train it around the United States, safety rodeos and things like that, if they say, hey, we want you to come with the trailer, I say, that's fine. and we're going to do open test ground on a pad mount, let's say, and have the linemen actually do it with their hands and get involved with doing it themselves, energized. So it's a lot of fun. But I tell them, it's like, look, I'll do it if I can do it this way, not open test ground. What we're going to do is we're going to test, we're going to open, we're going to test, we're going to test the tester, then ground. 5 steps. This is getting very popular, and I think this needs to be in the regulations as well. This method is sweeping across the United States. Okay, Encore just implemented it. All 900 linemen, they're doing it. So it's really cool. Consumers Energy, nice. So what we're going to do is, before we open the switch, this takes a little more time on the job site, doesn't it? Open, test, ground, compared to test, open, test the tester ground. It takes a little more time on the job site. And you know, we're a few employees down. We're always behind. We can't ever seem to get quite caught up with our work, our tasks during the week, okay? But the thing is we need to slow down because guys are getting hurt. See, folks think about production as far as priority, all right? And that is not priority, guys. You coming back home, that's priority, period, okay? It's actually not even a priority. It's a culture. It's your consciousness. It's a thought. It's your mindset. All right? This is why we did electric culture of safety. Okay? Because everybody thinks it's a priority. It's not. So what we're going to do is we're going to go ahead and test first. The reason why we're going to test first is because, remember the battery test, we finished that on this job site. We're at the middle, we'll call this some overhead lines. Okay? We're at the middle overhead lines here in Perryville. Right here. We're in overhead. And at this job site, before we open the switch, we're actually going to make contact. The reason why we do this first is after the battery test, you want to make sure your tool's calibrated. Say you're on, let's say this is 19.9 overhead. Okay? So you guys put 2400, 72. Okay. So let's say this is 19.9 overhead, which it's 19.9 underground, but let's say it's overhead 19.9. We want to make contact with the tool to verify the tool's working on a live known voltage source. That's important. So we're not going to just run and open the switch. So this is single phase. We open the switch, this is all we got. All right? So what we're going to do is we're going to go ahead and test the tester. We're going to on a live known voltage source, so we're going to test first. Okay? That's a big important reason. The second important reason, and to me, this is more important. And this won't be written in the regs, but maybe you guys can write it in your procedures. We did the tell board. You guys did the job briefing. You walked around. Everybody walked around. The apprentices walked around. The superintendent, all the journeyman linemen walked around. They came back, 2 minutes, came back, and they talked with each other. All right? Any concerns? Made a game plan. Everybody's got, okay, your quarterback. All right? You got a center. You've got your receivers, you've got your linemen. Everybody has a task, and you talk about it in this particular job. And you can change it up from time to time. It's fine. Maybe you're a center here, and you're tired of doing that, and you want to be a receiver. That's fine. All right? You do overhead, underground, so that's cool. All right. So you're going to talk about it. Now, here's the thing. You guys sign off on these sheets, right? You guys sign off your name. And a lot of times, it's almost like fast food. You know, you pay for your food, and it's like you give them the signature, your card or whatever, which is like a signature, and then you're done. And the thing is, when you sign off on that job briefing, you're never done with that job. It's continual. Your signature is alive. It continues. Okay? But there's a couple lines that are missing on these job briefings that need to be added. One of them is personal accountability. If you're on the job site with me, I want to know that you're going to be personally accountable to me that day. This center overhead line address. You're going to be at every job site. You're going to sign this sheet, and you're going to be personally accountable to me. You're saying to me, you're personally accountable. In other words, I know, and we can talk about this on the job site. Hey, did you sleep good last night? No, man, I stayed up with my friends. I drank until 5 o'clock this morning, and man, I'm dragging up, but hey, I'm here for you. Hey man, that guy there, or gal, needs to go home. Because there is no personal accountability with that person. You guys see this? This is why linemen are getting hurt. More than all the safety meetings that they're not getting, it's the mind is not focused. Sleep deprivation. You know, some of you guys have your eyes kind of closed now, and that's fine. But sleep deprivation, all right? You shouldn't be on the job site. If you're doing a little bit of, you know, maybe playing with drugs or something, you don't need to be on the line crew at all. Don't need to be there. Okay? Because you're not personal accountable to me. My wife wants me to come home. And guess what? Your kids want you to get home too. All right? We got responsibilities. You guys get that? So there's got to be personal accountability. You're going to sign that sheet. Also, there's another thing we got to talk about. All right? And that's mutual accountability. Mutual accountability is ongoing that whole job. You're watching out for me, and I'm mutually watching out for you on that job site. And I'm going to sign it, and we're going to talk about it. Yeah, man, I got your back today. I'm going to watch it. You guys don't have to like me. Maybe I stink. Maybe you didn't like the words I use maybe one day. Okay? Maybe I gave you a sign or a gesture and you took it offensively. None of this has anything to do, and is no excuse not to be mutually accountable one to another. All right? There is no excuse. You don't have to like me. You don't have to agree with me. When maybe I talk about things on the job site that I'm concerned about, you don't agree with. It's got to be safe to listen. It's got to be safe for me to speak for your apprentices. It's got to be safe for them to speak up, and you cannot demoralize them. You cannot put them down. Listen to them. I've heard several stories where a journeyman lineman speaks up and saves the lineman's life seconds after they got yelled at by the same lineman. True story. Okay? And he actually took a pause. He took a pause and then became aware of the situation, which his apprentice was aware. He wasn't. He yelled at the apprentice, took a pause, saved his life, got out of the bucket truck, gave him a big hug. And he'll never do it again. And there's no room for that in this industry, in your profession. You guys get that? Personally, you're going to be personal, you're going to be mutually accountable one to another. Okay? All right. So what we're going to do is we're going to test first. We got our direct contact detector, URD. Okay, these overhead lines are pretty low to the ground plane. Direct contact. Okay, reading a little high. We're close to the ground plane here. The meter head is close, to the source? Close to the ground plane. So it's a 19.9, so we should expect it to read just a little on the high side because of that. Because you know how these tools work in relation to the ground plane, but we got a trailer here close by, maybe a closed cabinet. All right, so it's going to read a little on the high side. We know how this works, so it's to be expected, but we know we're good. All right? So the tool's working. We're going to create a visible air gap. If the air gap is around the corner, you got, a ways away, that visible air gap's a ways away. You lock it out. When you come back to your job site, is it still called a visible air gap if you can't see it? No. So remember this. All right, then you're going to retest. So we test it, open, then we're going to test. And the tools, we know our tools, we're confident about our tools because these tools tell us we don't have induction, we don't have backfeed, and we do not have our system voltage. But how do you know for a fact that the tool is actually working properly? You think it is, odds are really high. But guys, we're not in Las Vegas rolling dice on this job site. So what we're going to do is we're going to test the tester on a live known voltage source. We got a 3 kV power supply and we got a handheld power supply. Right here. Test the tester. You all see that? Working, right? Test the tester. Okay. So now we are confident. This is a live no voltage source. We are confident. Not a lot of current, high frequency. It works great. Very safe. We are confident that our tool was working properly. We can go ahead and set our EPZ. Is that cool? Very safe. It's important. This is how we should be working. All right. Any questions thus far? Good so far? Okay. Now, from time to time, you're going to be in that situation to where your meter head, if you use whoever's tools it is, doesn't matter. If you're going to have a ground plane close by that meter head, a bleed wire or a close cabinet, or maybe if you're working a substation and you're going to visibly inspect your work area, your equipment, and you know that if you make contact with the conductor right there, that there's a hot bus that will be right next to the meter head. So you don't want that because you could have an arc flash because you know how these tools work. So you're going to use a zero ohm extension. So you're going to simply put it on the end of that tip. You're going to use a hook probe, straight probe. You won't use a bushing adapter on this overhead line, but it's close to the ground. We're going to use a bushing adapter. Okay? And that goes to another point. Do not use your tools, and this is important, do not use your tools, hook probes, bushing adapters, straight probes. Do not use your tools without them. In other words, do not use it by making contact with the conductor with the cone tip, the end of your tool. All right? That's called a shortcut. And we don't take shortcuts. You always want to use the proper accessory, because if you don't use the proper accessory, the opportunity, maybe you're working late, maybe it's foggy, the opportunity to lose your depth perception is much greater if you don't have the proper accessory. It's much easier, the opportunity to bypass that line limit without the proper accessory becomes enhanced, correct? So always use the proper accessory on the end of your cone tip, okay? A lot of the guys, their hook probe or their straight probe will be gone out of their kits. And for years, they will not use the proper accessory. All they had to do is just give us a quick call and order something. We have them. So make sure they're in your kits. Proper accessory. Don't want to bypass your friends there, the resistors. Okay? So what we're going to do is, so I'm working a substation, and we actually had this call once with a quarter. We'll talk about it in a little bit. And I know that I inspect, and I'm going to have a hot bus next to that meter head. Well, that's primary power. I got primary power here. I got primary power here. 2 different phases. We're going to have a cross phase. We're going to have a big explosion. And that actually happened in Texas. Okay? So I'm going to use a zero ohm extension. So I'm going to go from this to this. Then I know I'm safe. Okay? We don't use them often, but they're in our kits. If we need them, we got them. This is very popular now. And they're put them in their kits. It's really cool. All right. URD. We're going to go back to URD. Look. Got to be energized now, or it's not going to work. It won't be the same. It's overhead line. Okay? You see, you guys see those numbers? Those numbers are actually a little closer to that 19.9, right? 20,000 volts now. A little closer. All right? So, more accurate, right? Equals safety and accurate information gathering, correct? So, what happened? With the zero ohm extension, 2 things happened that are different now, physically, different than they were without it. What 2 things? I'm going to ask you guys a question. What 2 things have changed? 2 obvious things have changed. What are they?
Change your ground plane.
Yeah, awesome. Further from the ground plane. And you guys know how these tools work. Yep, that's one thing. Further from the ground plane. And One more thing. Nice. Love it. Further from another potential or the source or a source. I love this. Perfect. Okay? And that's what has happened. So that's what the zero-ohm extensions do. That's what they're for. Those reasons, right? So you know they work. We just proved it. All right. So those are neat to have. So I was doing some training in Tennessee. 2 linemen came to me and they said that there was an arc flash. What happened is the 2 linemen said that there was electric cooperative, and one of the guys, they were working a cabinet, and the cabinet was loose from its foundation. And one of the guys was working the hot stick, working the elbows. Okay, working the elbows on his hot stick. See this? He has his air dielectric. That's good, right? He's working those elbows. The other guy, what happened was he noticed the cabinet was a little loose from his foundation. So just remember, you all need a good foundation in your life. That's important. All right, but this cabinet had a loose foundation. So what happened was the other guy, they're working as a team. The other guy took his gloved hand and put his gloved hand on that cabinet and got arc flash. Okay. He was the ground plane that potential found and didn't ask permission, didn't knock on the door, give him a few seconds to think about it. It just went straight home. He got burned up a little bit, spent some time in the hospital, didn't lose anything. He's still working. All right? This is several years ago. And what they said in the incident report is they said the reason why he got arc flash is because there was rat piss in the cables. They stuck to it, and they got away with it. That's their story, and they stuck to it. Okay? So what happened was they told me this story, and I said, no. I said, that's not what happened. What happened was he coupled with capacitance just enough to where that potential found him. So I got gloves on. You guys see this? I got gloves on, right? So watch what happens to these numbers as I approach the meter. All right, the meter. Watch what happens to these numbers. What are they doing? Are they going up? See? That makes sense, doesn't it, to you guys? Makes sense, because it's closer to ground plane, right? So what happened was is that lineman, he trusted a good friend. And when he put his gloved hand on that cabinet, he kicked his best friend, air dielectric, to the curb. I was doing training in a large cooperative in Florida. And there's a big sign there said, always trust your good friends, your gloves, and your TPGs. And I told the operations manager that they need to tear that sign down and say air dielectric. Because gloves can let you down. You get too comfortable with a good friend and you push them a little bit and they might not work out for you that moment. Okay? So you got to be aware that you're coupling as linemen, when you guys are working hot, your body is coupling to a measurable degree with your job. That's just how it works. Gloves on, PPE, whatever. Maybe you got overshoes on for whatever reason, dielectric boots. None of that matters. You're coupling with your job. You're becoming one with your work, believe it or not. All right? So what happens is when you're using these tools, they're made this big. So the little birds land on the lines. The big birds, coupled with the capacitance, that charging capacity in them is much higher. And so they get uncomfortable in relation to the ground plane. They start feeling some shocks because they're a bigger body. The little birds can get away with it. So when you're using your tools, don't be X plus Y plus U and make that tool bigger than it is. Get away from it. See how that works? All right? Okay. So, Mr. Dillon, you ready? So Mr. Dillon's going to show you guys some things, and you need to pay attention. If you guys got your eyes closed, now's a good time to not close them. Then you stand up and watch this. Slap yourself in the face. Okay, so Dylan's going to use a PD25. This is the most accurate voltage indicator on the market. This is one of Walter's 17 patents. It's corded, so we're going to go phase to ground. The secondary probe will go to the ground, which is what we're going to call the trailer. Okay? And this device here, you can use it for testing lightning arresters to verify your regulator neutrals in the neutral position or not. You can high pot with it. You can find your leading phase out in the field with it. You can de-energize conductors with it, capacitors. You can also identify, because this reads AC and DC voltages, so you can use a 100-volt battery pack and you can energize a cable with 100 volts, go to the other side. This picks it up so you can ID with it too. Phase with it obviously, and verify voltage from 1 volt on up to 50 kV, and with some extensions you can go to 150 kV. Okay, so it's a very, we call it a multimeter. It does more work than any other tool in the industry. Seriously. Okay. All right, you ready, Dylan? Okay, man. Go ahead and take this E25 and that switch plate. Go to 2 kV. So 2 kV will work from 1 volt on up to 1999. About 2,000 volts. Right? Ready? So what we're going to do is, Dylan, you're going to go ahead and stand in the middle, if you could, and get a measurement. I'm going to work safe. Now remember, we're showing you guys truth, not theory. This is how electricity works, and when you work safe, you're energized by your work somewhat. Measurably so, you really are. Okay? If you work unsafe, you're even more energized, and it's unsafe. Both of them. That's another word I learned in South Carolina. Both of them. That's one word. All right? So what we're going to do is I'm going to get back on my stick. And Dylan, if you could read my foot, and then my back, and then the inside glove with the probe. Okay? Go ahead and make contact with my boot. And what you get as far as your voltage. Right on that boot.
157.
Is it? Yeah, that's pretty good. Pretty high. All right? Go to my back. Remember, this is 20,000 volts we're messing with here. Go ahead. What you got?
191.
191? So about 200 volts. Now, if you're on 7200 working safe, it's way less than that, obviously, right? Just do the math. It's pretty accurate that way. All right, go to the inside glove. What you get?
186.
186 on the glove. See that potential is flowing, isn't it? Right across that glove. Right across my body, right across from the tool, across my glove, through my body, to my boots. See? All right? Now I'm going to work unsafe. So I'm going to go ahead and short stick. I'm not going to do tool gloving though. That's a little too close. But I'll do short stick. Let's see the difference. Yes, sir.
161.
What you get?
160.
160, go to my back.
205, 206.
Okay, 205. Inside glove.
230.
230, 227. All right, you guys hear that? See the differences in those numbers? Big increase. But that's true. And you know that if you're working unsafe, that you engage with your work where you don't want to. So these minimum approach distances, that's why they make minimum approach distances, right? All right, so what I'm going to do is I'm going to go ahead and put on some overshoes real quick. Let's do it again. So, or let's say I'm standing on a rubber blanket, okay? So I'm going to put on these overshoes. Okay. Tactical safety. Kind of cool, huh? Tactical safety, you guys remember stuff. Guys remember stuff when they see it actually. You know, it's hard to read a book and see it reading a book sometimes. So this is kind of our little book right here. All right, ready? Okay, buddy. On the rubber. 167. Is that similar to before without them? It's similar, isn't it? Almost exact. Isn't that wild? Okay? Remember how electricity works. You walk underneath the transmission line, it's wet out, you're walking your dog, sometimes you feel a little tingle because that potential's going home to some measurable degree. right through you. Okay? It's reality. All right? Go ahead. The back.
197.
97 and inside left.
197. 198.
Okay? Short sticking. Same.
164.
64.
210.
210. Inside left.
246.
246. All right, y'all? Similar numbers. Okay? Short sticking. Pretty crazy, isn't it? That's what these overshoes on. All right, let's continue. Now what we want to do is talk about corded safety, working with the cord. All right, let me take this off. I'm going to turn this off. Any questions thus far, guys? Any questions? No, you can go ahead. You can turn it off and then go back to 2 kV. We're going to phase. All right, good. Come on over here. So we're going to phase on these capacitive test points with this tool. Show you guys how to do this. So when you use a corded device, remember you're going to stay. Let's say your work methods state and you're taught, trained that you stay 36 inches away from your meter, right? If you have a corded tool, you want to stay 36 inches back away and train and teach and do this in the field, 36 inches back from the cord as well, right? Because the cord is part of the tool, correct? See? Now our cord in South Carolina, what we do is we actually manufacture, we're the only manufacturers that do this. No one else does this. We build a cord inside a cord. It's shielded. No one else does this. This is shielded at 35,000 volts. So when you use this tool, you can actually have the cord on the ground on a metal box while you're using it. It's fine. But stay away from the cord. All right? It's just that we make our tools and our products safer because we can. We don't have stockholders that pad their pockets. All right? We have safety to bring you instead. We'd rather do that. Bring you safety. All right? All right. So what we're going to do is, Dylan and I are at this, we'll call it the left pad mount address here in Perryville. That's the address, left pad mount avenue. Okay? And Dylan and I are going over the job briefing. He had a good dinner last night, loved on his family, got some good sleep. So he's personally accountable to me this day. And we're mutually accountable to one another. We signed off on it. But signing off on it means we're engaging in it all day long. Okay? There's no signing off. You're engaging in it. Your signature is alive. It's your word. Contract. Him and I made a contract. So he agrees to be mutually accountable to me today. And I'm agreeing I'm mutually accountable to him today. So what we're going to do, we're going to phase the off-capacitive test points. But when we phase, what we're going to do, a couple things. We're going to go ahead and make sure the tool's working properly on the live known voltage source. Right? And then we're going to make sure our head's in the game. Why we do that? Okay? That's what we're going to do, making sure. All right? And then what we're going to do is we're going to look at the voltage. We're going to look at the voltage from one capacitive test point to ground compared to the other capacitive test point to ground. So Dylan, go ahead to your capacitive test point and read us the voltage.
See if it was 10.
Yeah. Yeah, there you go. What you got?
424.
424 volts. All right, and go to your other one.
335.
335. So about 90 volts difference. So each elbow has a little bit of difference of resistance, a little difference of location. All right, each elbow has its own fingerprint as far as the semicon material and own location. So you're going to get a little different readings off the, same potential. But what we're going to do is when we're phasing, you're going to take, because this tool is so accurate, you're going to take those differences, and I'm going to go to the other side of the pad now. And if Dylan sees on his meter head the smart side, he won't give me the smart side yet. I'm still learning how to do this. So he keeps a smart head. He keeps it. If he sees about 90 volts, which is the difference of the two, then he knows we're in phase. You take the difference, subtract it, and if you get close to 0, then you're in phase. See how that works? If you're out of phase, you'll see a multiplier of those voltages close to 600. You don't need a calculator. You just know. It's like way high. All right? That multiplier, 1.73 or whatever. All right, so I'm going to go to the other side. All right, ready? All right, man. Go ahead and go on that capacitive test point. And what you got? 71. So that's close to 90. All right? That's going to be our 0. We're in phase. That pretty cool? Real easy to use, very safe off capacitive test points. All right, man. Let's go. Let's phase in this panel up here. Right here. Come over here. We're going to go. Now remember that's energized. All right. So you go ahead to that middle phase. And what do you have? 118. 118. Phase to ground. Stay there, Dylan. What you got? 0. In phase. Stay there. What you got? 100. Oh, phase messed up. Stay there. What you got? 200. Close to 208. All right. This tool actually told me something's wrong with something's going on in this here. It's not reading right. So the tool told me that. Okay. This thing bounces around the road, so it happens where we get a malfunction in our equipment. 200. 205. All right. You guys see that? Out of phase. All right. All right. Now that we're going to phase these hot bushings, Dylan, or what's called our overhead line, grab your bushing adapter. And let's go to the table and take off your straight probe and switch it out with the bushing adapter. Okay, so when you guys make an equipment change, here we're changing our accessory off the end of our device. We're making an equipment change. It could be any tool change, equipment change, or anything. You're making a change. Notice how Dylan and I, instead of making the change right next to our energized source, Dylan and I take a couple extra seconds and a couple extra steps away from that and make our equipment change on our hot sticks. Okay? So regardless of what that equipment is, Dylan and I are going to move away from it, make the change before we re-engage. Takes a little extra time, and yeah, we're short a couple of hands in our service center, our particular area, maybe the north yard or the center yard or whatever. But here's the deal. If we don't take our time, okay, slow is smooth and smooth is fast. Okay? If Dylan gets hurt because we got something that we got to do, and man, we got to get this job done and go get this other. If Dylan gets hurt, not only are you down a couple of hands at your particular service center, but now you're down Dylan. Okay? What about his family? Are they down Dylan too? Huh? See, it compounds trouble. See, in this life, you guys need to understand that in this life that you live, that we all live together, it is designed to give you pressure. It is purposely designed so that you are always pressurized. And you just need to learn to chill. Okay? Hey, you might not get it done. Guess what? My guys, when I worked in Arizona, I had a company in Arizona. You know what my guys would tell me? Mañana. That's Spanish. It means tomorrow. And sometimes that's a good word to learn. They taught me. And actually, you laugh about it and everything, but I learned a lot from them. Mañana. We'll just do it tomorrow. And we'll go home today. Nothing wrong with that. All right? So make the change. Okay, buddy. So I'm going to go to ground. I'm going to go to ground. Trailer. Okay? Go ahead and do a reading on that top bushing. Go to your primary. Plug it in. There you go. What's your reading? 1. So the tool, Dylan's got it on 2 kV. So the tool's telling Dylan, and all of our tools speak to you. The tools, once you learn how these work, the tool's telling Dylan that he's got it on overload, that he's on secondary. So Dylan's going to take the tool back off, go ahead, and take the switch plate and go to 25 kV. He's going to tell the tool that we're working this high line, that's high voltage. All right? Not doing capacitive test points. All right, go ahead, buddy. What you read?
20.1.
About 20,000 volts. Good. True RMS voltage, plus or minus 1%. Now I'm going to go to the other side of the cabinet. We're going to see if we're in phase or out of phase. I go to the other side of the cabinet. Well, overhead line, I guess. Good night, Buzz. Okay. There's about a 0.5 milliamp that actually flows through that cable right now. What's your reading? 0.2. There's a little bleed on that cable. Hear the buzz? If this cable was laying in wet grass, it would probably show a 0.6, more of a bleed if it was wet grass. Okay? So we know we're in phase. Now when you're phasing with anybody's tools, you always want to take your secondary probe off first. All right? Always take it off first, or if you're high potting, anybody's tools, you always want to take that secondary probe off first to ground. All right? And the reason why is because when Dylan pulls that meter head off, Dylan wants to verify that the tool is telling him that the device, the cord and the secondary probe, the meter probe, he wants the tool to tell him, anybody's tools, that it's de-energized. But because it has resistors in both the secondary and the meter probe, Dylan knows that it's not instant de-energization. It takes a couple of seconds because of the resistors. But Dylan wants to get confirmation that it is safe, it is de-energized, so he's always going to take the meter head off last. Every time, every job site. You don't have to do it this way, but what is it? Understanding, right? Understanding, you guys are getting a lot of understanding today, equals knowledge. Knowledge equals safety. So you don't have to do things these ways, but you do things these ways because it's much safer, and we're watching out for one another, right? We're part of a team. We're all connected. Okay? All right, buddy, so I'm going to go to ground, and you're going to verify when you pull that off that tool goes to 0. Does it? Goes to 0. Safe. Isn't that cool? All right. All right, buddy. You could go ahead and put that tool down now. Do you all do any wireless phasing? Wireless? No? You want to see wireless phasing? You do? All right, let me show you wireless. It's more efficient, a lot safer. All right. Dylan, I'm going to have you help me. Dylan. Can't leave yet. They're demanding it. Okay. So what we're going to do is we've got some overhead up here, 7200, and we got a PD800W reference probe. That's the reference probe. It doesn't have the sun shield on it. There's no sun shield on it, so you know that's the reference probe. If it's energized, we turn the reference probe on, and we place the reference probe and hang it on that conductor. A white light comes on, hot or not. Then we know that that conductor is energized. Okay? All right. And then what Dylan's going to do is he's going to use the PD800W meter probe right here. And he's going to check out our conductors one after another. And we're going to be on an A phase. So if Dylan comes over here and touches the capacitive test points, and it starts working at 50 volts. It goes up to 800 kV. So secondary, all your primary, everything. All right. So if he touches the capacitive test points on those elbows, and he sees a white light and close to 0, the tool is reading the phase angle, not voltage. It's not looking at potential. If it sees that it's the same phase angle, then it'll be close to zeros, depending on leading and lagging power factors in the field. In this case, the generator, which is not very accurate, it's bouncing back 60 hertz, back and forth, so the tool doesn't like it, but it'll work just fine for this presentation. If he sees zeros, which is one indication, or close to 0, and a white light, which is your second confirmation, then he knows, because the reference is on A phase, he knows that these elbows are A phase. No difference. If Dylan is looking for a match out in the field, he's going to make a tie. He doesn't care about A, B, or C. If he's got a reference over here, and he's got the meter probe showing white light and zeros over here, regardless of the phase, it's a match. Now, if he makes contact with this hot bushing, so 300 volts here, he's got 20,000 volts here, and he makes contact with that hot bushing, and he's getting a blue light at about 120 degrees, then he knows that's the next phase out of sequence from A, that's a B phase. He knows that, A, B, C. If Dylan touches those capacitive test points over there, and he gets a red light, and he's seeing close to 240, then he knows that's the second phase out of sequence from A. He knows it's a C phase, 240 degrees. So this tool doesn't care if you're on the high side, low side. It doesn't care if you're comparing secondary with primary. It doesn't care about potential. It's just looking at the phase angle. All right, that's all it's doing. It's real simple. All right. It's also a great voltage indicator, like we showed you with our digital. This here, this second function, is as a voltage indicator as well, detector. All right, so it'll actually do great voltage readings just like that tool prior. So it does two things. You can phase with it, okay, and you can also look at the voltage, the potential, okay. So it does two things. But here on this job site, we just want to phase. Okay, John. Go ahead, glove up, and there's your glasses. Always make sure you have the dark lens and a light lens. Maybe it's real cloudy or early in the morning. Right? Yeah. Good. Can you see all that? Good. That's dark. All right, we'll get by you. You come this way. Okay, so I've got this reference probe, and I'm going to go to DEG, degrees. I'm not looking at overhead potential. I'm not looking at underground potential. I'm looking at the phase angle, so I go to degrees. And if it's energized, we'll see a white light. Okay? White light, we're energized. We already checked the battery. Batteries are good. So we already got the job briefing. Mr. Dillon here is mutual accountable to me and personally accountable to me today on this job site. So go ahead, Dillon. Yeah, go to degrees and go to that first pad mount there on your. Typically, when he's going on capacitive test points, he's not going to use a bushing adapter, but we're going to save time. Go ahead and just make contact with that. Go at the upper one so they see it easier. There you go. Yeah. It's not supposed to be a blue light. Yeah. We got an issue. This is messing us up. Huh. So, we got some travel woes here. It's wanting to go to 0. All right. So, we won't say nothing. We just know we got travel woes. Go ahead to the middle upper bolt.
Close to it.
All right. We got a blue light. See that yellow light blinking? If you see a yellow light blinking, it's telling you you're 30 degrees or 20 degrees more or more out of phase. So that's going to be an indication you're out of delta Y transformation. That tool's designed to do that. Here it's just telling us that that generator's not pretty accurate. But it's a blue light. We know that's a B phase. Okay, go to the last one. There you go. We got a red light, close to 240, trying 270. All right, so we know that that's going to be a C phase. All right? All right, go to the hot bushing. Upper one. Yeah, there you go. Okay. Blue light, close to 120. What phase is that? The phase our reference? B phase, that's right. You guys know. All right, now stay right there, Dylan. So if our reference, let's say we only have a known B phase as a reference. So instead of ABC, 0, 120, 240, if B's a reference, now it's going to be B, C, A. B is 0, C is 120, A is 240. See how that works? So watch that meter, watch what happens. Yeah. Yeah, we got some issues, man. We got some issues with our A. That panel right there is messing us up. All right, come over here. Yeah. There's Wansi go blue. Come over here on this remember, so C phase is going to be blue 120, close to that. All right, ready? Go ahead and pass the test. There you go. So 120, close to it, blue light. We know that's a C phase. All right, you guys see how that works? Just for the heck of it, if this is messing up, go ahead over to that last path now, Dylan. Get your steps in today. That should be good. So we got an issue here with that one phase. All right, so we got a red light, close to 240, wants to say 240. So we know that's an A phase because B's our reference, right? Good? All right, very good. All right. You can set that down on any table, Dylan. All right, so let's real quick talk a little bit more about safety. Hey, Dylan, can you shut down? There's a key on that generator. Can you take that key and go to the off position for us? All right, appreciate it. All right, so we're going to just real quick talk about a few things. We're going to de-energize. Okay. So, do you all have any questions as of yet? Any questions? Good? Any questions? All right. So, just real quick, I want to get into some psychological safety real quick. We do have a great battery-operated high-pot tool, a service tester that's a must-have if you all do any troubleshooting. It goes up to 800 amps, sources up to 800 amps. And you can identify your secondaries now with the receiver that works together with that. And you can identify primary cable with this. They work together. So it does a lot more than just testing secondaries. Cable ID tools, phasing tools from any distance, just with your cell phone and the tool we already showed you. So we got a lot of tools. So thank you, sir. Thank you, Dylan. So we got a couple things to talk about. One is Timothy R. Clark wrote a book several years ago called the four stages of psychological safety. And the first stage he talks about, it's a good book, you guys should get it, Timothy R. Clark. The first stage of psychological safety is that it's got to be safe. And this is so important, guys. It's got to be safe to be included. All right, there's a lot of folks out there with like major differences one to another, and that's fine. It's whatever, okay? But that's not what we're here for. Is to use those differences as a weapon, or use those differences as something that's divisive. All right, everybody makes choices, whatever, okay? But we have a job to do, and that job requires us to work safely. All right. So in our profession, it is so important that we work with each other and communicate, and we are all included. CEO, and this goes from the CEO from the ground men, all right, that just started the job, all right. Safety culture here is not from the safety man. The safety man is simply a coach. Safety culture is from one to another. All of us are in this safety culture, okay. So it's got to be, we got to have it where it's safe to be included. The next thing is, it's got to be safe to learn. All right? Some folks know more than other folks. All right? But everybody, you might know more line work than somebody else, but they might have more practicality. They might have more depth perception. They might have more understanding or reasoning than you do. You may be doing this for 20 years. They've been doing it for 3. They could be actually more in tune to things going on out there than you. for that particular day. You just don't know. Okay? Here's a sine wave. Okay? Here's our attitude. Okay? This guy's attitude, his perception could be up here, and your sine wave could be on the negative side of the sine wave, right? You don't know that day. We don't know. All right? We got all this going on. It's compound. There's a lot of complicated things going on psychologically. So it's got to be safe to learn. We got to learn from each other. And the best way to learn from each other is to listen and watch. You don't have to say nothing. All right? Just instead of opening up your mouth all the time, listen and watch. That's how you. When I in Arizona, I used to love bow hunting bull elk, and I used to always trophy hunt bull elk, and I got really good at it. And you get really good at bow elk hunting, and you don't even want to use a rifle. It's just not fair. It's way too easy. Okay, and I watched them, I listened to them, and I learned from them. I didn't talk to them. Okay, but I became smart. I became like them. In essence, I did. And we got to connect with each other. Okay, we got to communicate with each other. It's got to be safe to learn. All right? This other thing we're going to talk about. Third thing, third stage, is it's got to be safe to speak up. It's got to be safe to speak up. We're on a job site, and you see something, and maybe nobody else brought up. And you just don't want to bring it up. You're maybe a little scared, and you don't want to say something because you could be put down. Okay? Well, every one of you all have in your DNA a signature, and part of that signature that's in all of your DNA. You need to believe this. It's true. In all your DNA, part of that signature is warrior. You're all warriors. You all are. You actually are. Okay? And the warriors are going to speak up. And warriors take care of their other fellow warrior, the other linemen. And you're going to speak up. You're going to talk. All right? Don't be afraid to speak up. Hey, if somebody puts you down, then they got some learning to do. They need to learn to make it safe to learn from one another. Okay? So you got to speak up. This is so important. Lito Wilkins came and did a training. It's a great video. He was working transmission as a contractor, PG&E in California, and his webinar from last April was 003, Lineman Safety National Webinar 003, and it's called My Shocking Awakening. Okay, you listen to that video. You guys got to watch it. You watch that video, you'll get a little tear in your eye, man. He shouldn't be here. Okay? A lot of you guys shouldn't be here. I shouldn't be here. None of us. We've gotten so many things in our lives, close calls, close misses. We shouldn't be here. He shouldn't be here. But he talked about how they were on this tower and they were changing out bells. Helicopter. They were changing out bells. And it was the first day. You can't make this up. It was the first day they had fall restraint. Very first day they had fall restraint in their truck. First day. And guess what? They went up on the tower because they weren't comfortable using their fall restraint. They didn't wear fall restraint that day either. But they had it in the truck. You can't make this up. He got up on the tower. They talked about it on the ground, and they were looking at some of the equipment, and there was a cable coming down. There's a ground cable coming down. And they talked about it. We should be fine. We should be good. And they didn't check it. Absence. They didn't have the tool. They didn't use the tool to verify an absence of abduction, an absence of abdominal, an absence of back feed. They didn't do that. So they're on this tower. He's going across to the other side, from one side to the other side, and he's got his foot here, and he grabs a hold of that cable. His wrist is kind of touching the frame. Grabs a hold of that cable and locks up. And he can't let go. So as that induction bleeds to ground, through him to ground, it's his wrist. His wrist is welding on that cable, and the lug in his boot is welding on the bracket below him. Slag. You guys ever welded before? Okay, see that slag? So that's happening to him. And he's calmly thinking in milliseconds time. This is, you know, when things happen, you know how sometimes it's like real slow, but it's like happening so quickly. He's thinking to himself calmly, I need to let go. But if I let go, I need to fall back. And if I fall, I may not have a landing. But there's some angle iron behind me, and the angle iron, I'm hoping when I let go, catches me. So as it bleeds the ground, he's about 6 times he went through these cycles. At the 6th time, he was just able, and he was trying to before, there's other cycles, as it bled. He was just able just to release enough. And he did, and he fell backwards on purpose. Not knowing if that was his last day or anything, but he couldn't keep holding on. And he fell backwards, and it cradled him, held him. Okay? And they took him to the hospital. They're in the middle of Timbuktu, California. It took like 2 hours to get to the hospital. They took off his boot, his shoe, and they could smell the burnt flesh. He didn't know it before. Took off his boot, and it was all burnt. Anyways, he spent a few weeks in the hospital. He's now a safety guy for international line builders in California, northern region. Great guy, all right? That's one of the videos you can have. But we just don't know, guys. And we got to watch each other. We got to speak up, all right? So speak up. And then it's got to be safe. Here's the 4th stage of this psychological safety. The 4th stage is it's got to be safe to challenge. It's got to be safe to challenge. So a CEO, if he's amongst his folks, and there's an apprentice that has something that is worthy to speak up and worthy to learn from, it's got to be safe within all of us to challenge one another. All right? That's how we grow stronger. That's what my sister says. She says, I give you a hard time because it makes you stronger. Okay. So I travel. Get away from her. Okay? But anyways, it's got to be safe to challenge. So we have to challenge one another to do better, to be better. All right? And part of this culture, this electric culture of safety, is the psychological safety. So, you know, several years ago, 2 guys were changing out a broke pole in Michigan. All right? And they knew the lines were hot. They were working hot, and they knew it. 2 guys were working. One guy was taking the log out of the trailer with the boom. They knew it was hot. The boom hit that energized line at the same time. His best friend and his partner was reaching in the truck, getting out some gear. And in a split second, his wife lost her husband, the kids lost their dad. 20-year journeyman lineman. 20 years. You don't think they ever had a class that said you cannot lift the boom, let it touch the energized line as your partner is in the truck gathering gear? Do you not think they had that class? So the guy working the boom, was he mutually accountable to the guy in the truck? Was he? 50%? How about 0%? 0%. He just wasn't. And the guy that was in the truck, getting the gear out of the truck at that same time, do you think he was mutually accountable to his best buddy that now, because he's gone, has to live with that weight on his shoulders that his best buddy died because he wasn't mutually accountable, but because he was in the truck, he wasn't mutually accountable to his best bud, and now his best bud has to carry that weight on his shoulders because he's alive with his family having fun, birthdays and doing all the things and celebrations and grandma and grandpa. But this guy, smoke. You see how this works? 20-year journeyman. Do you not think he had safety classes? Do you not think he had safety sessions and conferences and this and that? Of course he did. He knew better. But see, guys, you can have all the safety you want. You can write books. You can take these safety books. You can put them in a blender and drink liquid safety. That does no good if you don't apply it, and you got to live it here and here. Make sense? Okay. All right, guys. So that's it. I hope you guys live it, man. You gotta live it, okay? We got these flyers up here for e-cause. We got our Facebook and LinkedIn groups. It's free safety, all right? Any questions at all? Good?